Okay, students. So now we are going to discuss Coulomb's law in vector form. Okay. Suppose we are considering here two charges, two positive charges Q1 and Q2. They are separated by distance r from each other. Now these two are positive charges, so definitely they will repel each other. And what happened basically, you will see that the force on the first charge due to the second one, that is F12, and this force F12 will act away from Q2. Similarly, suppose F21 is the force on second charge due to first one, and this will act in this direction. So these two forces are acting away from each other, they will repel each other, and they are separated by a distance, say r, from each other. And r12 cap is the unit vector directed from Q1 to Q2. Similarly, R21 cap is the unit vector directed from Q2 to Q1. Okay. Now, if we want to write the Coulomb's law in vector form, then how can we write? See, now what happened basically? Uh, Here we are finding that this one vector form, when we are writing the Coulomb's law, then F21, that is okay. Let me show you the first one figure, you can understand easily. Yeah, then F21, that is the force on the second charge, force on the second charge due to the first one. F21 will be equal to 1 by 4 pi epsilon naught Q1 Q2 by R square R12 cap. Okay, why? Because see, F21 we are taking force on Q2 due to Q1. So on this one, the force is along this direction. Along this direction, the unit vector we can take is your R12 cap. Similarly, where R12 cap is what? R12 cap is done nothing but R12 vector by R. This you got in class 11, isn't it? How to define unit vector? Unit vector is nothing but the vector divided by its magnitude. So unit vector from Q1 to Q2. Similarly, one can write the Coulomb's law for the force on the first charge due to the second one. That one, of course, you can see here. F12 is not it. This one we can better show you like this. Yes. So now you can see here from the diagram. F12 will be 1 by 4 pi epsilon naught Q1 Q2 by R square R21 cap. Now since R12 cap is equal to minus of R21 cap, because the R12 cap is in this direction, R21 cap is in this direction, they are opposite directions, so R12 cap equal to minus of R21 cap. Therefore, F12 vector is equal to minus F21 vector. This equation number 2, and the other one which we written earlier, that is equation number 1. These two are the Coulomb's law in vector form, and from here you can easily conclude that. Can you recall this one? This one basically is Newton's third law of motion, where we understand that the force on the first charge due to the second one is equal and opposite to the force on the second charge due to the first one. So we can conclude that Coulomb's law obeys Newton's third law of motion. This is one point regarding Coulomb's law. Another point is that this Coulomb's law, as Coulomb's force, is a central force. Why? Because the force acts along the line joining the two charges. As you saw here, that the force which either this direction or that direction, but it acts along the line joining the two charges. And if a force acts along the line joining two charges or joining two bodies, is known as a central force. So Coulomb's law is Coulomb's force is a central force, you can say, is not it? So that's basically about the Coulomb's law in vector form. Limitations of Coulomb's law is that you know Coulomb's law is not applicable in all the situations. It is valid only in some conditions. With some conditions it is valid. Electric charges must be at rest. Electric charges must be point charges. That is, the extension of charges must be much smaller than the separation between the charges, and separation between the charges must be greater than the nuclear size. That means 10 power minus 15 meter. Because for distances, if you are considering less than this one, the strong nuclear force dominates over the electrostatic force. So that's about the Coulomb's law in vector form. Okay, thank you.